Hello, welcome guys to my YouTube channel. Today we are going to discuss a new chapter of mathematics class 10, which is real numbers. So in this chapter we are going to talk of LCM and SCF and some real numbers properties. First, LCM. LCM stands for lowest common multiple, as you have already studied in your lower classes, and SCF, which is known as highest common factor, is also been studied by you in your lower classes. Next important point in this chapter is that for any two important integers a and b, SCF of the number into LCM of the number gives the multiplication of the product of the two numbers, which is specified by this relation. Okay, to understand this, we are to understand more on SCF and LCM in this chapter, we are going to concentrate on a problem. The problem statement is the find the SCF and LCM of 672 and 120 numbers using the prime factorization method. So here in this question we are given three numbers, which is 672 and 120. So if we look into this problem, we'll see the first 6 we can write it into 2 into 3. 72 we can write it to the power 3 and 3 to the power 2. 120 we can write it 2 to the power cube 3 into 5. This you can easily solve by a factors, and HCF if we'll calculate of 672 and 120 will give you 6. Now important point here to note is that in SCF we are having three numbers. SCF stands for highest common factor. So if you see the highest common factor in 672 and 120, you can find that 2 is present here, 2 is present here, and 2 is present here. Highest common factor is 2, and here 3, 3, and 3. So we have here 2 to the power 1 and 3 to the power 1, which is equals to 6. Next, LCM. LCM if you calculate, it comes around 360. LCM stands for lowest common factor. So consequently you can also calculate this. Let's take another example. Given that SCF and LCM of 306 and 657 is 9. Find the LCM. So here in this problem again we are using the formula which I have stated in the earlier part of this chapter. SCF is given 9. So here we'll multiply the product, take the product of the two numbers, say 306 and 657 equals to 1042. We'll use the relation SCF into LCM equals to the product of the numbers. So if we'll rearrange this equation and put the values in the equation, we will get LCM equals to 22,338. So as you can see, it is very easy and simple to calculate the LCM and LCF. Now let's discuss one theorem. Let P be a prime number. If P divides A square, then P divides A, where A is a positive integer. So this theorem states that if P square is divided by A, then P also divided by A, provided P is a prime number. Now let's understand this with the help of an example. The question is, prove that root 3 is irrational. So in solution, let's assume on the contrary part that root 3 is a rational number. So as and when we consider it as a rational number, we can express it in the form of A upon B, where A and B are integers. Rearranging the equation, we get A equals to under root 3b. Squaring on both sides, we will get A square equals to 3b square. Therefore, if we see this, A square is divisible by 3, as we can see this in the equation 1, then by above theorem A is also divided by 3. This is what the theorem explains. Again, if A is divided by 3, therefore we can express this is a equals to 3c, where c is an integer. Squaring again both sides this, and we obtain a square equals to 9c square. Equating the equation 1 and 2, we get 3b square equals to 9c square. Hope this is up to till now everything is explained. Further solving this equation, we get b square equals to 3c square, but this means that b square is divisible by 3, and consequently b is also divisible by 3 using the theorem. Therefore, a and b must have a 3 as at least a common factor in between them. But this contradicts our fact that a and b are co-prime, which we have taken in the earlier case. So this comes to a conclusion that root 3 is an irrational. So hope this example is very much clear to all of you. So today with this example we are coming to conclusion of this video. Thank you for your time. Kindly like, subscribe and share this video.